Section 7.6 is all about function operations. Today, all we're going to do is add, subtract, multiply, and divide functions. You actually already know how to do these things. The only thing that's going to be different, I guess, is the dividing, maybe we haven't done as much of, and the notation of how it looks. So normally if you were adding functions, this is what it would look like. And you guys know if you're adding, all you do is add your like terms, so the parentheses are really irrelevant. You would just get x squared, 3x plus 1x is 4x plus 7. That's adding functions. But instead of having just the numbers in parentheses, you're going to see function notation, like f of x and g of x and some notation stuff. The division will also be a little bit different in terms of if we have quadratics or linear or what. So the warm-ups at the top ask us to, first of all, find the domain and range of each function, because that's going to come up in today's lesson as well. So remember that the domain is the set of all x values. And the range is the set of all y values. So for the first one, it's just a relation or a set of ordered pairs. So the domain would just be the x values, 0, 3, and 4. We usually use braces to recognize that they're a set of values. And then the range would be the set of y values, -5, -3, -1. Now the next two are actually functions. They give you an equation that you could think of graphically, sometimes helps you to think of domain and range, but you could also think of them algebraically. So what would the graph of 2x minus 12 look like? What shape is that? Hannah?
A line.
It's a line. Have a y-intercept of -12 up 2 over 1, something like this. Okay, so again, if you remember, our domain and range we did a lot with in chapter 5, which were all quadratics, remember? So similarly, you're going to see domain and range in this chapter that will deal with linear, quadratics, cubics, and even square root functions that we'll see. So think about the domain, which is your x values, and the range, which is your y values. What do you think the domain of this function is? What are all the possible x values that could show up on the line? Garrett? That's one of them. But -12 would actually be over here. You're thinking of the y. But I'm not looking for a number, I'm looking for a range of values. Hannah? Yes, we'd switch those around actually, but yes, you're correct. So the smallest it will ever get is -infinity, and the largest it will ever get is +infinity. And that's because on the x-axis, this line goes down forever and ever and ever, which means it actually goes out to the left forever and ever and ever, and up to the right. Another way you can write this is all real numbers, which is like a bolder looking R. So 2 lines and then an R. Now the range should also be all real numbers are -infinity to +infinity because it's going down forever and it's coming up forever. Now number 3 is a quadratic. We know it makes a parabola shape. And this is actually the parent function, which starts at 0, 0, and goes up. What do we think the domain of that function would be? Remember, domain, think of your x values. Think of your x-axis. What's the smallest on the x-axis it will ever touch? What's the largest on the x-axis it will ever touch? Jade? Good. All real numbers are -infinity to +infinity because of the arrows going on forever and ever, left and right. Now the range is not going to be all real numbers. Sam? Good. The smallest on the y-axis it ever gets is 0, and the largest is infinity. So we do put a bracket instead of a brace or a parenthesis because it actually touches at 0, comma, infinity. If you didn't want to write it that way, you could say y is greater than or equal to 0 is another way to write that. But I prefer if you use the interval notation because that's what we'll see mostly in pre-calc and calc. So you'll see me write it that way, just like I did in chapter 5. And then the last one for the warm-ups asks you just to evaluate each function for the given value. So if the function g of x represents this quadratic trinomial, find out what g of -3 is. So if you're asked to find out what g of -3 is, all we have to do is substitute in -3 for x. If you're doing it by hand, which we should all be able to do by hand, you want to make sure you're doing order of operations first. And we'll get 18 plus 9 plus 1, which will get us 28. If you're using your calculator, make sure you use parentheses appropriately, or you could store -3 in for x, and then you could type in the x functions. All right, so what we're going to be doing today, as I mentioned, is operations with these functions. So we'll be adding, subtracting, multiplying, and dividing. So this is what the notation will look like within the two functions. So the addition will look like this, f plus g, and then it's of x. This is the same thing as f of x plus g of x. So anytime you see this, just realize you're taking the first function, you're adding the second function. Now multiplication has a closed dot. Tomorrow, which hopefully I'll have time to introduce it, you're going to do composition of functions, which look like this. Okay, it has an open circle. So you want to pay really close attention to whether or not the dot in between is closed in, which means multiplication, or if it's open, and sometimes it's not as large as the one I drew on the board. If it has an open circle, you'll be doing what we learned tomorrow, which is composition of functions. It's different. Subtraction, of course, we have our subtraction symbol, and dividing, we'll see a division bar instead of the division symbol. Notice that it says g of x cannot equal 0. Remember, that's because this is a denominator. And we always say that one of our restrictions, remember we did restrictions on the variables, were that the denominator can't be 0, and that's because the function wouldn't exist at that point. So that will affect your domain. Otherwise, most of our functions are going to have all real numbers for domain, as we saw in the warm-ups. All right, for number 1, we are given two functions, f of x and g of x, and they want us to find out what the sum of the functions is and what the difference of the functions is. So our f plus g of x is equal to f of x plus g of x. So we literally just take the two functions and we'll add them together using like terms. So f of x is 5x squared minus 4x, and g of x is 5x plus 1. And then we just combine like terms. The parentheses are really irrelevant because adding, you distribute a positive one, doesn't do anything. So we'll get 5x squared, negative 4 plus 5 is 1x, and plus 1. They also want us to describe the domain. So most of you will benefit from thinking about this graphically. The domain of this function, this is a quadratic. The domain is still going to be all real numbers, or negative infinity to positive infinity. They also ask us to find the difference of the function. So f minus g of x, which is equal to f of x minus g of x. So this time the parentheses are useful because we're going to have to distribute that negative to the second set. So this will be our 5x squared minus 4x minus the function 5x plus 1. Distribute your negative, and then combine your like terms. So we should get 5x squared minus 9x minus 1. domain, since this is a quadratic as well, is still going to be all real numbers, or negative infinity to positive infinity. So you guys can try number 2 on your own. So remember, linear functions still go on forever and ever and ever, whether they're positive or negative. And so we will get all real numbers. On the back, we have multiplying and dividing, which just take a little bit more work because we'll have to FOIL, distribute, or we may have to factor the numerator and denominator and then cancel out binomials, something we did earlier in the year in chapter 5 when we looked at simplifying rational expressions. So for number 3, they want us to find f times g of x and f divided by g of x. So again, this is the same thing as f of x times g of x. And so we'll do that part over here. And we'll split this up to have our division on the other side. So f of x is a quadratic trinomial. G of x is a linear binomial. And we've done a lot of these throughout chapter 6, where we had to distribute a bunch of times, and you're going to have to do that. So start with the 6x squared. This needs distributed to both of the other terms. So that'll get me 12x cubed minus 6x squared. Go to your next term, the 7x, distribute it to each of the terms in the second binomial. So the 7 times 2 will get me plus 14x minus 7x. And then lastly, distribute the negative 5. Make sure you include that symbol negative. And we'll get a minus 10x. And then 2 negatives here will make me a positive 5. And you just have to find any of your like terms and combine them. Uh-oh. I've lost an x squared somewhere. This should have been 7x times 2x, which was 14x squared. My bad. I knew I shouldn't have 3 like terms then. So just combine our like terms there, and we will get 12x cubed plus 8x squared minus 17x plus 5. Now, if you remember our cubic functions, sometimes they came up, they all depended. Sometimes they looked like this. They had those relative max and relative mins. Some of them were a little bit not as steep as that, but still, they're going to go forever and ever and ever, left and right. So the domain will still be all real numbers, negative infinity to positive infinity. When the domain is going to change is when we have a denominator, or if we have a square root, are going to be our 2 big things, which is probably going to happen in the next one. So for our division of functions, this will be f of x divided by g of x. So substitute in your functions, we'll have 6x squared plus 7x minus 5 all over 2x minus 1. Now what you cannot do, 100% cannot do, is just cross off like, oh, 6 and 2, make that a 3. Remember, these are quantities. The only way that you can simplify is if you can cancel out a whole binomial with a whole binomial. So, we did these back in chapter 5. We need to factor the top, factor the bottom. This bottom isn't going to be factorable, but sometimes it is. And then if we have common binomials, we can cancel them out or divide them out. So in the top, this is a harder factoring. So guess and check. Now, hint, probably you're going to get 2x minus 1. Like you're most likely going to have. So that tells you that you could start with 3x and 2x instead of starting with 6x and 1x, just by using the denominator as like a context clue. And then I'm thinking this is going to have to come out to be a minus 1, which would make this have to be a positive 5. And then let's double check. We'll get 6x squared minus 3x plus 10x, which is 7x, and our minus 5. So use the denominator as a context clue to help you. So now we can divide out those whole binomials to leave us with the final answer of 3x plus 5. Now, if you just look at this, you would tell me that the domain of this is all real numbers, right? Because it's a linear function. However, there was a part that we had in our original function that is no longer in our final answer. So normally the domain would be all real numbers, but we have an exception. We have a restriction on the variable. The denominator of a function can never be 0. Otherwise you get a divide by 0 error. So you have to take the original denominator, the 2x minus 1, and tell me that it cannot equal 0. Remember doing this in chapter 5, where we'd state restrictions on the domain? So we would then add 1 to both sides, divide by 2, and so we'll get x cannot equal 1/2. So there's two ways that you can write the domain then. You could say all real numbers except x cannot equal 1/2. Or you can use interval notation. This is probably how most of you will prefer this way. But the interval notation would be negative infinity to 1/2. And you would put a parenthesis because you don't want it to actually ever touch 1/2. And then you'd have to put a union symbol, which is a U, which unites it with another set. And this would go from 1/2 to infinity. So what this is allowing you to do is basically skip over the 1/2 because it's not included there and it's not included there. But you're covering every other value that would be existing beside those two. So those are the two ways you can represent the domains. Okay. All right, see if you guys can try number 4, finding your product and quotient of f of x and g of x, and see if you can figure out the domains. The biggest thing I want to make sure you don't do is that you don't think you can just like subtract this 2 and the 4 and get a -2. Like that only works if these were being multiplied, but since these are binomials, they're grouped. So don't use your exponent rules, okay? Factor it, and then you can divide out your like terms. You do want to make sure you leave a 1 placeholder in the numerator. And then it's up to you whether you want to leave the denominator x squared minus 1, or you could factor this and make it x plus 1, x minus 1. Because this is actually factorable. I don't care which one you put. I would accept either answer. So it didn't tell you whether you should expand or simplify. Now our domain is going to be all real numbers except what? What numbers are not allowed to exist to make this function work? Jade? 1 and? Garrett? Nope, it could be 0. 0 to the 4th is 0. 0 minus 1 is -1. Hannah? -1. Okay, so what you have to realize is if you take this denominator, remember that the restriction is that the denominator cannot equal 0. So x squared minus 1 cannot equal 0. We add 1 to both sides, we square root, and as Mrs. Bennett always says, don't forget your plus or minus. Okay. If you factored it, it's actually easier to see that there's both answers, but it can't be. So for this one, you could say all real numbers except x cannot equal positive or -1. If you're doing the interval notation, it's actually a lot longer. I'll show it, but I wouldn't. It would be negative infinity to -1, union -1 to 1, union 1 to infinity. Because you just have to skip over the -1, then go from -1 to 1, that's allowed, and then skip over the 1 and go up to infinity. So most of you would prefer the except part of everything. But this is what it would look like interval-wise. All right, the last ones are pretty much the same as what we've already worked on. The only one I want to do with you is the B, letter B here, because it has this -3 in front. I think you probably could figure this one out on your own if you needed to, but it says -3 g of x plus f of x. So that's -3 times g of x, which we'll want to use parentheses around, and then plus f of x. And then from there, you just have to distribute and combine like terms. But just make sure that you realize that this is being multiplied by that function. then you just have to combine like terms. They did not say we have to state our domain on this one, so we won't, but it would still be negative and positive. See if you guys can finish up. Yeah, finish up A, C, and the closure. I guess I'm not going to get to intro the other lesson. Anyone have questions on those? Garrett? The closure? So just be careful, this one says G minus f of x. The order has been changed. So you have to take the g of x function and subtract the f of x function. So they switch that order around at the end. And that does change with a subtraction problem. Then distribute your negative. And so 2 plus 4 is 6, and negative 6 minus 1 is a negative 7.